All right, this is Honors Algebra 2 Pre-Calculus. We're doing 7.3 in Algebra 2, second video of the section, which is factoring polynomials. So, quick reminder that we've done all of this already with the exception of the last step. So, if you're factoring, first thing, if it's an equation, please make sure you move all the terms to one side so that it equals 0. Beyond that, you're going to go through the same factoring checklist that we did in Chapter 5 and that we talked about before that, probably in Chapter 2 or 3. So first, you're going to look for a GCF. If there's a GCF, you're going to factor it out. If it's a binomial, you're going to see if you can use one of the two special patterns that we learned in Chapter 5, even though you technically weren't supposed to learn the second pattern until now. If something is a quadratic trinomial, you're going to try factoring it into a product of two binomials. If there are an even number of terms, you're going to try grouping. And lastly, if all else fails, we're going to learn to try synthetic division, which is what we learn in this section. So let's go ahead and start factoring again. Cool. So we're going to fully factor each polynomial. Remember, the first thing I should do every single time is look for a GCF. Even when there's a much more complicated thing going on, there's often a GCF at the beginning that makes life a lot easier. Here, I can take out a 3x, and if I do, I'm left with 2x minus 1, and that's it. It's just a GCF with leftovers. For b, I see that there's a GCF of a 10x, and if I take that out, I'm left with an x squared minus 9. Well, this is a difference of squares. Right? This is an x squared minus a 3 squared. So this is a difference of squares. Difference means subtraction. So I get a 10x, which is my GCF, and the difference of squares will factor into x plus 3, x minus 3. That's not what I wrote, though. I wrote a 9. Sorry, my bad. I said 3. I wrote 9. There we go. Sometimes my brain. All right. So for C, this is a binomial. There's no GCF, right? There's nothing in common. So there's nothing in common. It is a binomial, and they're both cubes. So this is that a cubed plus or minus b cubed pattern, right? In this situation, my a is just x, and my b is a 4, right? The pattern is a, so keep the sign, plus or minus b, right? A squared minus or plus ab plus b squared. So keep the sign, change the sign, always a positive. So this is going to be a plus 4, because I kept the sign, x squared minus a times b, which will be 4x, plus b squared will be a 16, right? It is worth noting that this is always prime, meaning it doesn't factor, and has no real zeros. So there are no real roots, no real zeros to this trinomial. I promise you that's the case always and forever. I'm more than happy to walk you through why. So moving forward, go ahead and try a P3. So you're going to go ahead and factor this. Feel free to pause me if you want. So first thing I do is look for a GCF. I find that I could take out a 5x squared, and I am left with an x plus 4, and that's it. For the second one, I see that I can take out a negative 8x, and what seems to be left is an x squared minus 1. Well, that's a difference of squares. So I get negative 8x, and then x plus 1, x minus 1. For the last one, there's no GCF, but it is a binomial, and I notice that there are cubes, right? So this is that a cubed plus or minus b cubed pattern. Keep the sign. Change the sign. Always a positive. So in this situation, my a is x and my b is a 3. So keep the sign, x minus 3. Change the sign, x squared plus 3x, and then always a positive. Again, that trinomial is always prime and will never have any real roots. All right, cool. So let's keep going. All right, so the first thing I do in A is I look for a GCF. There is no GCF. I see that the 5 has nothing in common with the 12. So once I know there's no GCF, I say, cool, this kind of has to be a 5x and an x. This is either a 1 and a 12, or a 2 and a 6, or a 3 and a 4, right? Since I know that the front seats have to be a 5x and an x, I can write them in. This minus tells me that the signs are opposite. So what I'm looking for is I need an OI that subtracts to negative 28, right? Opposite signs. So I want a negative 28, and I think, okay, well, my best bet seems to be a 30 and a 2, because if I make this a 6 and I make this a 2, those would subtract to a negative 28. I want a negative 30, and a positive 2. And then I should always do a quick FOIL to check, right? So I should always do a check. This can be in your head. I don't actually write out my checks on paper. I'm only writing them out because I'm trying to teach you some math. So first would be 5x times x, which is a 5x squared. That's correct. Outer and inner, well, the outer would be a negative 30x and the inner would be a plus 2x. Yup, there's my negative 28. That's the thing I was worried about. And my last is a negative 12, which is correct. So you should always, it's fine if this is in your head, but you should check, because if you're wrong on the factors, it's going to cause this weird like snowball effect where it's going to cause you to be wrong on lots of other stuff too. All right, for B, there is a GCF, right? So for B, there's a GCF of a 3x. And after I pull that GCF out, I have an x squared plus a 7x plus a 12, which is going to factor a lot easier. So this is a quadratic trinomial. But I know the front seats have to be x and x. I know the back seats have to have the same sign. I look at 1 and 12, 2 and 6, and 3 and 4, and I realize that the only ones that are going to add to 7 are 3 and 4. So this is a 3x. It's an x plus 3 and an x plus 4. And you can double check, right? You should always check this in your head. Right, your first would be an x squared, your outer and inner would be a 4x and a 3x, which is a 7x, congrats, and your last would be a 12. So again, you just want to do a quick double check. This can be in your head. I'm never going to care if you check, I care if you're wrong, right? Go ahead and try a P4, same basic thing, right? So here I've got a 3x and an x, and I look at 8 and think, okay, that's a 1 and an 8 or a 2 and a 4. The plus means they have to have the same sign, so I need them to add to a negative 10. Well, I know I have a 3x and an x, so my thought, if I want them to add, right, I want them to add to a negative 10, is that I probably want the 6 and the 4, because together those would add to the negative 10. So this is a negative 2 and a negative 4. If I FOIL to check, and again, you don't have to check for my benefit, I just need you to be right. The first would be a 3x squared, outer, right, would be a negative 6x, inner would be a negative 4x. Oh, look, there's my negative 10, check. And my last would be a plus 8, right, that's last, check. Okay, so there's my answer. And again, that check can happen in your head. When I look at B, there's a GCF. You're going to have a much easier time if you take out the negative 2x. It's a lot easier for us to factor quadratic trinomials if our leading term is positive. So I'm going to get an x squared plus an x minus a 2. And I look at this and say, okay, that's an x and an x. This has to be a 1 and a 2 with opposite signs, so I can factor this pretty quickly. X and a 1 and an x and a 2. Since I want them to net positive x, I need the 2 to be positive, so I get a positive 2, and the 1 to be negative, so I get a negative 1x. And you can certainly FOIL to check that, but that's the gist of how that would work. All right, so now we're going to do a couple more, right? We're going to start with factoring by grouping. All right, so for example 5, we're going to keep factoring, but this time we have more than 3 terms. So let's go ahead and try factoring this. So first thing we do is look for a GCF, and there isn't one. The easiest thing to spot to tell us there isn't a GCF is this negative x. Not everything has an x. There's no way we can take a number out of it. So there's no GCF. It is clearly not a binomial. It is clearly not a quadratic trinomial, so we try grouping because I have an even number of terms. So I'm going to group the first 2 and group the last 2 and see if I can see group GCFs. So I can take out a 4x squared from the front and be left with an x plus 2. I can take a minus 1 out from the back and be left with an x plus 2. So now there's this hidden secret GCF. I can yank out the x plus 2, and I'm left with a 4x squared minus 1. Now, under some circumstances, I'd be done. This is definitely done. It's a binomial, but it's not squares or cubes. But this is a difference of squares, because this is actually a 2x quantity squared minus a 1 squared. So to fully factor this, I'm going to get an x plus 2, a 2x plus 1, and a 2x minus 1. And that is fully factored. All right, so let's go ahead and try B. So the first thing I'm going to do is look for a GCF, and sure enough, there is one here, right? There's a GCF of x, and I'm left with x cubed plus 5x squared plus 3x plus 15, right? So this bit's done. But then this piece in here, right, is not, it doesn't have a GCF because I already took out the GCF, right? I did that piece. It's not a binomial. It's not a quadratic trinomial, but it does have an even number of terms, so I'm going to try to group, right? And sure enough, if I group this and this, I'll see that there is a secret hidden group GCF. So I can yank an x squared out of here and be left with an x plus 5. And I can yank a plus 3 out of this one and be left with an x plus 5. So now I have this new secret group GCF that is an x plus 5. So I have the x out in front that hasn't moved the whole time, the x plus 5, and what's left is an x squared plus 3, which does not factor because it's not a difference of squares, right? It's a sum, right? X squared plus 3 doesn't factor, and that's my answer. All right, let's go ahead and give a P5 a try. So you can try this without me if you want. Go ahead and pause me. So same set of options. I try for the GCF. There's no GCF, right? I can see that because there's no common factor. There's no x in all of them. There's no number in all of them. It is not a binomial. It is not a quadratic trinomial, but it does have an even number of terms, so I can try grouping. When I group the first two and the last two, the first two have a GCF of x squared, and I can yank out that x squared and be left with an x plus 4. I can pull out a negative 9 from the back two and also have an x plus 4. So now I have this new secret group GCF. So I get that this is an x plus 4 times an x squared minus 9, but this one is a difference of squares, right? This is prime, that one's fine. So I get x plus 4, and then since x squared minus 9 is x squared minus 3 squared, it's x plus 3, x minus 3, and that's my answer. All right. Last one, right? So first thing you're going to do is you're going to look for a GCF. We always look for that first, and there actually is one. There's an x. Once I pull that out, I get an x cubed minus a 3x squared plus a 7x minus a 21. So then I look at this thing in the inside, right? And it doesn't have a GCF anymore because I already took care of that. It is not a binomial. It's not a quadratic trinomial, but it does have an even number of terms, so I can try grouping. So this x just sits here. In here, I group the first two and the last two. The first two have a GCF of x squared, leaving me with an x minus 3. The last two have a GCF of 7, leaving me with that same x minus 3. So there's my secret group GCF. So I now get that this is an x times an x minus 3 times what was left, which was the x squared plus 7. That is a sum of squares, or, because 7 is technically a square, just like 3 technically was too. 7 is root 7 squared. Either way, it's a sum, so it's not going to factor, and that's my final answer. All right, that's it for that video.